Hey everyone, welcome to part 2 of my beginner workshop for side effects with Project Grot. In the first workshop, we've been focusing on how to create fracturing for any kind of object to create interesting rock-like shapes. In this part, we want to focus on flesh-like structures that give everything a lot of depth and detail. I think it's important to keep in mind that proceduralism can do a lot, but I think at a certain point, depending on the project that you're doing, you need to let go of the wheel and give control back to the artist. So what I mean is, like, as you can see, there's a lot of these floating rock-like structures that are attached to flesh. And in the beginning, these were all done randomly. And it looked pretty cool, but the problem was that when our environment artist Leia asked me, well, what if I want the rock to, be somewhere else though? All I could really say to her was, choose another random seed. But that's not really an answer to a problem. And so the more time we spent iterating on this tool, the more we realized, we just need to cut this up into 3 different tools. And I want to talk about these 3 different flesh tools today. And we're also going to recreate them. So the first one is the ruins flesh itself. And that is from the structure of the ruins, there's flesh directly attached to it to add this interesting detail to it. Then we have the flesh clusters, which are individual rocks that you can place that will then attach to a nearby surface and itself. And then we have the flesh webs, which is another standalone kind of spider web-like structure that gives interesting organic patterns. And the way it works is we bloat the level, we scatter a bunch of points and measure the distance to them, and then we can mask also some of them, and then we start doing a few steps to fuse them together and also check where there's intersections, and then turn it into geometry. So just to see it one more time, the magic basically lies in this step where we start connecting them together, the points that we scatter. But no worries, we're gonna get over this in detail now. All right, let's go to Houdini. So in this project, I've prepared 3 different tools. So the first one being the most simple one, where we just create a sphere, and the sphere can be moved. And then as it moves, it will connect to the nearby surfaces. So you can imagine basically that whatever we're seeing here is like our Unreal environment, and the sphere is an input that we give it. That could be a rock, or I don't know, it could be anything that you want. The second tool that I've created is something that is resembling the flesh cluster tool, where you can see that these spheres are now also connecting to each other. And as a side note, they are driven by a curve. So we can move the curve around and then the spheres will move. So instead of directly placing an object, we're just drawing a curve and the objects will appear. And then lastly, something resembling the flesh webs. And just to show again, as I move my sphere, the tool adapts. And the coolest thing about all of this is that all of these 3 tools are basically the same. And this is also how I did it in the real Project Grot, is that once I realized that there is an overlap between all these different flesh tools, it was really easy to create new flesh tools that have slight variations to them. Because at the end of the day, all that was going on was that I had 2 points, the beginning and the end, and I connect them to one another. And all you have to do is define the rules. What connects to what? How are they connect to each other? And that's what we're going to talk about today. So we're going to start off with the basic flesh generator, and then we're going to make copies and variants, and I'll take you along to show you how I managed to make several tools out of one. Okay, so the first thing that I do when I create a tool like this is I need some kind of placeholder, right? Because the thing is, you have to remember that as this project was going along, the environment that this tool was supposed to be created for didn't exist yet. But I needed something to know that it would work in any kind of environment. So the easiest way to go about this is to just create a fake environment for ourselves. So let's just get a grid. And I want to displace it, make it a bit noisy to imitate a rock-like surface. And for that, I'm just going to give it a bit more subdivisions, and then I'm going to get a mountain node. And this will add some more interesting details to it. We can maybe increase the element size and the amplitude to make it a bit more interesting. Yeah, it looks good. And then I want to scatter some random rocks on this surface. And what we can do is we can get the scatter and align node. And this will place random points with random orientations on it. And then I'm going to get a copy to points node. And I'm going to copy a platonic solid on this one. Platonic solids are cool because they're more interesting shapes than you would normally find. You know, something like an octahedron or something. It looked kind of rock-like, I think, you know, on a very with a bit of imagination. And then I'm just going to merge this with my grid. And now we have something kind of rock-like. I think this is kind of resembling of the cave that we're going to get later on. Okay, and before we keep adding stuff, I think it's a good idea to talk about organizing your graph. I think it saves you a lot of pain down the line. So, and it's relatively easy also. All you have to do is create a null node. At least that's what I like to do. And whenever I reach a certain milestone, I like to drop a null node and name it with something that I can remember. So for instance, this here later is going to become our Unreal Engine input. So this is not going to be part of our tool. This is just for us to test right now. But later on in here should come the Unreal input. So I'm just going to call this in for input, I guess, and then Unreal environment. Okay, so this will be our environment. And then I'm going to get a sphere for the sphere where we're going to spawn the flesh from. And I'm also going to get another null node. You can just alt click and drag if you want, or just, you know, search for null node. And I'm going to connect this in here, and I'm going to call this in and then underscore influence mesh. Okay. So now we have two inputs. And what I would like to do next is, well, as you saw in the breakdown video earlier, the first step was to load my environment, and then I'm going to scatter a bunch of points. So the first thing I'm going to do is I'm going to get a scatter node, and I'm going to put this right after the Unreal environment. And I'm going to get a bunch of randomly scattered points. And if you've watched the previous workshop on fracturing, you remember that we have this force total count slider, which defines how many points we're going to get. And that is really useful when you have something like a fracturing tool where you want to define the exact amount of pieces. Like, you know, you want to type 200, you're going to get 200 pieces. But in our case, I think it would be better to instead drive this on a density basis. So just to show you what I mean, if let's say I have 140 points. If I now go back to my grid and I keep increasing it, so let's say I make it now 50 meters wide, I'm still only going to get 140 pieces. However, if I instead switch from a force total count to a density scale, no matter how big or small my level is, the density of the points will always be the same. Okay, so now that we have these points, how do we connect them to my sphere? Well, I don't want to connect them directly to my sphere, also because I don't know what kind of object I'm going to get, right? This sphere is just a placeholder for whatever I'm going to get later. But what I would like to do is I would also like to scatter some points on this to connect them. So, cool, now I have these points and I have these points. But just as a precautionary measure, I don't want to leave all of these points because this, right, like this is a lot of points. Even just right now we have 2,000 points, and actually this is not that dense. So what I want to make sure is that before I connect the two, I want to discard all the points that I don't need. And the way that I want to do this is by making sure that only what is within a certain radius gets kept. And this is pretty easy to do. All we have to do is we have to get a node called mask from geometry. And we can plug in our points into the left input, and we can plug in the input of our influence mesh into the right input. Okay, not much is happening, and that is because we haven't really done much yet. Because all we've been doing so far is happening invisibly in the background. What we've been doing is we have written what's called an attribute to our points. We can use a mask attribute, and this mask attribute goes from 0 to 1, and the value is defined by the proximity of each point to my mesh that I put in. And it becomes more clear when I visualize this attribute. So let's just go over here to our little I button and then press mask. And you can see now that we have something like a heat map. And if I increase the radius slider on my mask from attribute, we can see it's a bit more obvious, especially when I start moving my sphere around. So you can see that we have this kind of like a radius in all 3 dimensions from this object that we have. So what can we do with that? Well, the cool thing is now we have an attribute, a piece of information that tells us how close our points are to our object. And what we can do now is we can see, like in our geometry spreadsheet, we can see that there's a lot of points with values, but then at some point it drops off to 0. And these are all these dark blue points that are outside of our radius. And what I want to do is I want to discard all these points that have a value of 0 and only keep what is above a certain threshold. And to do that, we can get a blast node. So at this point, you might already be familiar with groups and, being a selection that says something either should be applied or should not be applied. But what you might not know is that you're not limited only to groups using a node, but you can also write attribute values in here. So for instance, I could tell this blast node that it should blast every point with a value, with a mask value lower than 0.1. So if I go to my blast node, make sure to set it to points because we want to blast points. And then I'm going to say here at mask smaller than 0.1. And here we go. Now every point that has a mask value of less than 0.1 is deleted. And we can also check if we click on our mask attribute, we can see that the smallest value is a little bit over 0.1 and no points with 0.0. And as I move my sphere around, we can see how the points are dynamically appearing and disappearing around it. Okay, so this is already a really helpful step because now we only have the points that we want to keep. Oh yeah, and as a cool side note, well, as we increase this mask radius, we are also increasing the amount of points that are in our vicinity. So this is a really cool parameter that you can control later on in a user interface. Okay, so now I have these points and I have these points, but how do I connect the two? There's a really cool node called connect adjacent pieces that does the job for us, but it might not work exactly how you expect it to. So let's just merge both of our points because we want to pool everything that we want to connect together in one space. So now we have our sphere points and we have our environment points, and we want to make sure that we connect the two. So put these into connect adjacent pieces and we can see that nothing happens. Why is that? Well, it's giving us a hint, but I'm not going to get to the solution right away. I want to show something else first. But we can see that the hint says invalid attribute specification, attribute name either not used or unrecognized. Okay. But let me just show you what would happen if we just let it connect everything with everything, right? So let's just go from connection type, adjacent pieces, let's go to adjacent points. Okay, so now we can see that there is something going on. As I increase the search radius, we can see that things are starting to connect. And it gives us a kind of, it looks really interesting for sure. And it has almost like a spider web-like look to it. But it's way too overkill in the amount of connections that we're getting, especially on the surface itself. We don't really want the surface to connect with itself. We only really want these connections where the sphere connects with the surface, none of the in-betweens. So how do we control that? Well, as the first warning has tried to inform us, is that we're missing a certain attribute, which is called name. And if you remember, or if you've watched the previous video on fracturing, the name attribute is something that comes up over and over again when you're working with Houdini, especially in the context of separating different objects. In fracturing, the name attribute is being used to separate one piece from another piece. In the connect adjacent pieces node, we can use the name attribute to tell which point belongs to which group, and if they belong to the same group, they are not allowed to connect with each other. However, if they are not from the same group, then they are allowed. To demonstrate, let's just create a simple name attribute, one for the environment points and one for the influence mesh points, okay? And to do that, we just are going to get an attribute create node. And we need the name attribute, so we're going to type in the name, we're going to type name. The name attribute always has to be a string type, because most, or I think all the nodes that work with a name attribute expect it to be a string type. So just make sure to change that to string. And then we can type, for instance, we can type in 0 or ASD or blah, you know, anything. It doesn't really matter. All that matters is that they don't have the same value, that they are different from another, okay? So let's just get another, let's just copy that, get it over here. I'm gonna call this one 1. All right. So now if we go back to our connect adjacent pieces, we can see stuff is happening, stuff is appearing. So, and that is exactly what I've been talking about, is that we need this name attribute to tell it what belongs together and what doesn't. It might be a bit hard to really see what's going on because we only see the connections and not the environment, the context of this where this is taking place. So what I like to do when I'm working on a prototype is that while I'm still working on it, I just get a merge node. And I'm just going to put everything that I have in there. So I'm going to get my connections, I'm going to get my influence mesh, and I'm going to get my Unreal environment. Okay? Oops. Here we go. And now it's a lot clearer to see what's going on. And that is, well, what we wanted to do worked, kind of. It's still looking a bit geometric, a bit not organic, but it's pretty far where we want it to be. So, what I would like to do next is two things. First off, I want to discard everything that is inside, right? Because you can see, I don't know if you can see it that well, but a lot of the connections are inside inside other geometry. For instance, here we can see it really well that the connections are sometimes shooting through an object and ending up clipping with the environment, and we don't want that because it just doesn't look good, and also because the step after that is that I want to turn this into real geometry, right? Because right now it's just a spline with no thickness, but I would want it to look a bit more flesh-like, and I want to avoid unnecessary polygons. So I would just like to discard everything that's intersecting. And also that's a really helpful thing to learn, to remove intersecting geometry, I think, in general. So how do we do that? Well, before we get into the geometry part of it, like turning it into actual fleshy geo, let's talk about discarding. Okay, how do we discard these lines? Well, the thing is, we can use something that we've learned in the previous workshop on fracturing, and that was how we approached discarding pieces that are intersecting with a piece of geometry. If you haven't watched it, no worries. I'm gonna get into it. It's also a little bit different, but the idea, the principle is pretty much the same. So if we enable this ghost view, the template flag, we can see which of the lines are intersecting with our environment. However, if I would now try to just get a group node and group them by bounding regions, the result wouldn't be so satisfactory, and that is because well, we need points that are inside a bounding object, and as you can see, all of our splines just have a point at the beginning and a point at the end. But I also want more points in between so that we can register intersections a bit more reliably. And what we can do is we can just add more points. There's a really cool node for adding more points to a spline, and that's the resample node. So let's just focus on one of these splines here to make it a bit more easy to understand. So let's get the resample node. And you can see that it just adds point in a regular manner. That's really cool. So basically it tries to keep the shape exactly the way it was. And we can then say in the length parameter how large the distance between each of these points is supposed to be. And well, the smaller the length, the more points we're going to get, basically. And the cool thing is that this makes the tool work independently of this makes this work independently of the length of the connections. So you might have really small connections, and then you don't need as many points as you need with a longer connection. So maybe let's take something like, I'm thinking 0.05 might be a good value. Basically, we're just trying to strike a good balance between enough points that they are reliably being detected in an intersection and not too many that it becomes overkill. So now what we can do is we can take the geometry that we had earlier, our Unreal environment, and we can use this as a bounding object for our group node. So let's just take our resample, get a group node. Make sure to set the group node to points. Also, I'm gonna give it a name that I can remember, so like blast, right? Because I just wanna blast the geometry, so I guess that makes sense. And then I'm gonna go to keep in bounding regions and make sure to change it from bounding type, bounding box to bounding object. And it's gonna error if you don't have an input because, well, there is no object. So let's just get our Unreal environment and put that in there. And we can see it's registering something. And exactly the parts that are intersecting are being registered. So if you look closely, you can see that here, this part that is going into this platonic solid is being detected. Okay, and now what I would like to do is, if even just one point, like here, right? This one is, there's only one point that is intersecting, but I still want to discard it. So how can I do that? Because if I would just blast these points now, I would only remove these points, which, you know, if that's what you want, cool. But in my case, I would like it to, even if it's just one, I want it to expand until the end and then remove the entire thing. And the good thing is there is a node for that called group expand. And all we have to do is we have to just go to the group and then just say which group we want to expand, and that is the blast group. And we can see that our group is showing up, except now it's a little bit bigger, and that is because the expand node has this neat little slider that lets us like increase or decrease our selection. And even if I max it out, I don't get all the way there, so I could type in a really high number to make sure it gets all of them. But what you can do instead, if you know that you wanted to always go until all the way in the end, is you can just say flood fill to connected geometries. So even if just one of them is selected and I press that, it's going to go all the way to the end. And make sure to also give it the same name, blast, here, or if you want to differentiate between the original group and the expanded group, you can call it a different group like blast expanded. In my case, I just wanted to stay blast. But yeah, make sure to change this name. Because next what we're going to do is we're going to get a blast node, connect that here, and then I'm just going to get the blast group, and here we go. We have removed all the intersections. And we can also see that a bit better when we connect it up to our final end result. Okay, and just enable, disable. And we can see that now the intersections are gone. Well, not all of them, because we still need to make sure that we get the intersections from our sphere, because our sphere also has intersections going on. But that is really easy because all we have to do is add to our Unreal environment, we also have to add our sphere. And so basically all we have to do is we just go to our group node where we plug in our bounding object and just get a merge node before that. You could just drop it onto the connection and then plug in our influence mesh. That's it. That's the cool thing about procedural systems, right? Once you have a system set up, it's really easy to keep adding new things or to make it behave in a different way. So the last thing I wanted to do was I wanted to add this thickness to it. And there's a really cool node for that called sweep. And basically what sweep does is it takes a curve and then it applies a profile to it. So this could be anything you want actually. And in the beginning, like the standard behavior is it expects you to supply a profile. In my case, I just want a round tube shape. So if it's erroring out for you, go to surface shape and then say round tube, and then you get a round tube shape. But in theory, you could have a heart or whatever shape. This can be really helpful for a lot of other tools, and it's not. There are other nodes that do something similar. For instance, the poly wire node behaves in a similar way. If I plug that in, and it works straight away. Here, increase the divisions. But the reason why I wanted to show the sweep node is because it can do a lot more. For instance, it automatically comes with perfect UVs. So if you enable compute UVs, you have these really nice looking UVs. You don't have to worry about that. But this is not why I wanted to show it to you. Why I wanted to show it to you was because you can also affect the scale, and that is a really cool thing that I took advantage of in this project. So because right now it's very they're very straight looking, right? Like it's just a straight line with the same thickness all the way. But what I wanted to do was I wanted the ends of each curve. I wanted to have a bit more thickness to give this impression of you know, like muscles or neurons connecting to a nearby surface. And it's really easy to do. All we have to do is enable this apply scale along curve toggle. And then we have access to the scale ramp. So you can enlarge this by pressing this little button here that says maximize ramp. And then we can just add a few nodes, and you can see immediately when I move around, it changes the 3D model, and it's being affected by it. And what I want to do is just in the beginning and the end, I want to add these little, like a drop off, so that it gives this impression of like flesh like growing in a bit more, give it a bit more thickness. And to make it look a bit more smooth and organic rather than this very linear, you know, this sharp drop off, right? It's a very straight drop off. We can also affect the interpolation of this graph here, this ramp. So to get it to look a bit more smooth, we can click on each of these little handles down there. And where it says interpolation, you can switch it from linear to B-spline. And you might not immediately see something, but once you start clicking on the other ones and changing it, you can see that now they're becoming more like, it's becoming a bit of a more round fall off. So just go on all of them and change it to B-spline. And that looks much better. One thing I would like to maybe add is that in my case, I didn't want this to stay open. And to close these little holes here, we can go to our sweep node. And then if you scroll up to where it says end caps, you can change it from none to, for instance, grid. Grid gives you these neat little rounded balls here, or you can just do a single polygon to just cap it off. In my case, I like this. Also, you might notice that it's a bit thick. Well, I mean, this doesn't look too bad. But if in your case it ends up being a bit too thick, you don't have to change the scale over here, but you can change like the overall radius of the thing here in the radius slider. Yeah, it looks pretty good. And now maybe to finish it off, I can add some color to it. So just to make it look more like flesh, I'm gonna add a color node and make it look a bit more, yeah, like this. That looks cool. All right. And basically now we have something that very closely resembles the flesh tool of Project Grot. And it's really cool. Like you can immediately see it almost looks alive. Okay, so, but in the beginning of this workshop, I mentioned how these other two tools are basically the same thing. So how did I make them behave in such different ways, right? Like these connect with each other, and this one doesn't even connect with anything. It just connects with the environment. So how do you do that? Well, the answer to all of this lies in the name attribute. And I want to drive the point home by just copying. Let's just take everything that we have and let's just copy it one time. Also to like preserve what we had so far. So the next thing I want to do is I want to turn this from having our sphere that we can move around into something that is like the flesh cluster tool, where I draw a curve and then the curve becomes a sphere, or in our case, in the real tool, each corner of our curve became a rock. So how do we do that? The first thing we have to do is we have to change the sphere into a curve. And in Unreal, this would then become like a curve input. So whoever is using our tool would, just be in Unreal, and they can draw a curve like this. And on each of these points, something would appear. And in our case, to test it, I'm just gonna plug that in here. And I'm gonna get a copy to points. and spawn some spheres on it. So let's just reset this. Oh. Okay. Okay, so now we have these spheres here. I would like them to be a bit higher up. So in Unreal, you know, you would move the curve around. So let me, it's a bit more finicky in Houdini, so let me just move the curve manually by, let's say, 1 meter maybe. Yeah, that looks fine. Okay. And again, just to mention this again, you don't have to use a sphere, right? This could be a Megascans asset, this could be a rock that you made procedurally, or whatever you like. And what we have to make sure is that this curve that we now have, we have to make sure that we don't directly pass on this curve, right? Because now, in the beginning when we had our sphere, the scatter was being applied to the sphere, but now it's being applied to our curve. So we need to make a little bit of an adjustment to take that into account. Okay, so instead of passing on the curve to our scatter, we're going to take our copy to points. So I'm going to move that here, and I'm going to plug that into my scatter. Okay, so now we have that looks okay now. And we need to make sure that in our mask from geometry, we also pass on our spheres instead of our influence mesh. Okay, yes, that looks good. Anything else there? Let me see. No, I think that looks okay. Oh yeah, the last thing is for our blast node, right? For our group where we want to make sure to check for intersections. We also need to make sure to change this from the influence mesh input to our copy to points output here. Okay, good. And without really changing anything else except the order of where we plug things in, we already have basically a tool that, and also for the output, right? For our merge, we also want to make sure that we don't have the curve, but we have the copy to points. But yeah, that's it. So now we already have a tool where instead of now manually moving a sphere and then, you know, it becomes a spawn object for Flash, we now have a curve. And so if I now go and play around with my curve, we can see that, you know, I can just move these points and now my spheres are moving. But there's one thing that is missing, and that is because, as you remember, what I've talked about in the beginning is that when some of these spheres were close to one another, they started connecting to each other as well. But it's not happening right now. And why is that? The reason why this is happening has to do with the name attribute. Because remember, the name attribute, what it does is it tells our connect adjacent pieces node which points belong together and which don't. So, and again, everything that belongs together is not allowed to connect to one another. And because now our new system, it has 4 spheres, but all the scatters have the same name. They're all called, if you look at the geometry spreadsheet, they all have name 1. What we would need instead is we would need each of these different spheres to have its own name, right? Sphere 1 has name 1, name 2, name 3, name 4, and so on, to get the result that we want, to allow them to connect with each other. Luckily, this is really easy. So what we can do is, instead of having our one attribute create, we can just, we can delete that. And instead, before the scatter node, we can add a connectivity node. And connectivity is a really cool node, by the way, that you can use for a lot of other things than what I'm showing you. Basically, what it does is it looks at whatever meshes you're giving it. So for instance, here I have 4 spheres. And what it's doing is it's applying a value to each unconnected piece. So basically, if we look, if we enable the visualizer for the class attribute, we can see that each of these spheres has now its own color, because Houdini recognizes that they are not the same shape. So for instance, let's say you don't have to copy this, like you can just watch this for a moment. So let's say I have these 2 points and I turn them into a VDB. So I'm gonna get the voxel mesh node. And that would, make the 2 spheres melt together. So they are one interconnected piece. So now the connectivity node would mark them as one, but the other 2 are still marked as individual pieces. If I disable this, we can see that they get 2 different values. So this can be really helpful because now we have a unique value for each of these input objects. And all we have to do now, because we see that it's called class, all we have to do now is change the name from class to name, okay? Well, there's one more thing we have to do, because if you remember, the name attribute always has to be a string. So we just have to change it from attribute type integer to string. And the cool thing is, though, that the scatter node, it inherits the values of anything that it scatters on. So because, for instance, this sphere has a name value of piece 0, the scatter will inherit that. And now any point that was scattered on this object now also has this unique value. So if we now go back to our connect adjacent pieces node, we can see, well, or if we, let's go to the end result, we can now see that there is this connection happening between the 2 spheres. So let me just move them around again. Yeah, exactly. So this is the kind of behavior that we were looking for. And all we have to do is add this little connectivity node. And if you disable it, it disappears. If we enable it, it comes back. So we really didn't have to do that much, right? So all we had to do was change it from a sphere to a curve, make sure to rewire the things correctly, and then we just needed to add this little connectivity node. And it was done, and we have a new tool. So how do we do this last tool that I made, the flash webs? Well, the flash webs tool is really interesting because it works a little bit different than the others and requires a bit more tweaking, but it's relatively easy, and I think you can use what you learn from this one for a lot of other tools going forward. So what I'm going to do is I'm going to go back to the first graph that we made, and I'm just gonna copy that over here. Let's take a look back again to see what we're dealing with here. So you can see that we have a sphere, and then in a certain radius around the sphere we have these flash connections appearing. And so you can see that basically most has stayed the same. We still have a radius. We still have a radius of influence, and then we keep that radius, and then anything within this radius should connect. Except this time we don't want to connect to our sphere, we want to connect to anything but the sphere. So everything should connect with everything. But then we run into a little problem, and let me illustrate that. Okay, so let's get back to our little graph, and I'm gonna just make some changes. So first what we want to do is we want to remove everything that has to do with connecting the sphere to anything, okay? So we don't need the merge, we don't need the scatter, we don't need the attribute create on anything sphere related. Whoops, wired that up in here. But now it's not working. And why is that? Well, it makes a lot of sense, because remember, we have these points and they all have the same name, because in the beginning we gave all the environment points a value of 0. So that means all of them belong to the same group, and that means they're not allowed to connect with each other because we told them to. So how do we get around that? Basically what we would need now is we would need a unique value for each of these points. And the good thing is all these points already have a unique value, but we just need to find a way to access it. And what I mean by a unique value is, well, if you look on the geometry spreadsheet, each point has a number. And we can also see that number by enabling the display point numbers button over here. We can see that each of our points has its own unique index. And what we can do is we can take that number and we can apply it to the name attribute. We can just take that number and put it in as a value. So how do we do that? Well, of course you don't want to create a million different attribute creates, but there's a really handy node called enumerate. And basically what this node does is, well, make sure to change it from group type primitives to points so we can see. And basically what it does is it creates this index attribute where it does exactly what I said. For point number 0, we have an index of 0, 1, 1, 2, 2, 3, 3, and so on. And like with the connectivity node, all we have to do now is make sure that we change it to the right name that the connect adjacent pieces node is expecting, which is the name attribute. So let's just go back to our enumerate, change it from index to name, and type integer to string. And if we go back to our connect adjacent pieces node, we can see that stuff is happening. All right, it's working again. But it's not exactly working the way we want it to, because that is a problem. That is the problem that we're facing now, is that, well, the connect adjacent pieces node is basically within the rules that we have told it. It's trying to connect to the closest available point because it's the cheapest option, so to say. But I don't want that, right? I don't necessarily want, right? You can see this looks weird. It looks like a bunch of molecules or something scattered all over the floor. What I would like is a bit more longer connections happening on this surface. And the cool thing is there's a parameter for that called minimum distance. And what we can do with that is we can force the connect adjacent pieces node to discard all the results until it matches our criteria. So if you just play around with that with really small values, so let's just increase this slowly, we can see that these little things are starting to get bigger and bigger and bigger until it looks kind of like the flash we had earlier, right? So this is already looking better. But I feel like there aren't so many flash connections going on. And earlier we had way more, and I want a higher density. So I want to go back to the scatter node and just increase this density scale. But watch what happens now. The more I increase the density, the more appear, but at a certain point you start to notice that the opposite starts to happen. Suddenly they start disappearing until they're all gone. What is that? Well, the thing is, the connect adjacent pieces node has this parameter here, this setting called max search points. And what that means is that when we have a bunch of points, each point is allowed to look for 100 points in its vicinity, the 100 closest points. The thing is, however, if there are, like in our case, we have a maximum amount of 100 points, so each, like this point is allowed to search for 100 points and then connect to the one that matches. However, once we say we have a minimum distance of 1 meter, that means if there's more than 100 points within 1 meter, it won't find anything. And in this case, because we've driven up the density, we have more than 100 points around each of these points, and then they're all getting discarded. So to work around that, what you can do is you can just increase the max search points to allow it to keep searching. And that is something that you need to keep in mind. So it does, of course, lead to a lesser performance, but that's just something you have to think about. So as we increase the amount of maximum search points, we get more. And you can also play around with the minimum distance. On top of that, you can also allow each point to connect to more than one point. So we can say maximum 2 connections, 3 connections, and so on. And it's looking really gnarly, really fast. And again, make sure that you keep your budget in mind. In our case, we were pretty free to do whatever we wanted, but you might be in a different situation depending on what you're working on. So I'm already pretty happy with this. This looks really cool, really nasty. But there is one thing that bothered me, and that was that it was a bit too, it's a bit too straight, right? I mean, the connections are shooting all over the place in all directions, but they're still very straight lines. And what I wanted for these webs, like the name suggests, is I want it to be a bit more spider webby. And I want to show you a really cool trick how you can do that quickly. Of course, for the real thing, I put a bit more time and effort into it, but I want to keep this simple, but I still want to show you how you can kind of mess around with that. So let's just go to our connections. And what we can see is, well, we have all these points now, remember, right? From the resample, when we were discarding objects, we added some more detail. So now we have all these lines with additional detail, which is nice because now we could do this thing where we can have this thickness that is falling off based on how close to the ends we are. But we can do another thing, and that is we can connect these points to each other to kind of mess around with these straight perfect lines. So let's just get a fuse node, for instance. And then you can see that, so let's zoom in on a part here, for instance, and we can see that as I increase my fuse, my snap distance parameter from the fuse node, we can see that some of these points are starting to connect with each other and are creating this kind of interconnected web. And that is pretty cool already. Like if we just look at this on itself, it looks pretty cool already, because now we have this like, it became from something very straight and forward connecting, it became something a bit more messy and interconnected. It's still a bit digital looking, and we won't really be able to fully get rid of that within this workshop, but I want to give you pointers on how you can explore this on your own time. So for instance, what we could do next is I could resample this result again. Let's get a resample node. And what you can do is, well, first off, we can make it a bit smaller so we have more points. But what we can also do is, where it says treat polygons as, we can say instead of being treated as a straight edge, which means try to maintain the shape as it was before, as it was coming in, we can also say treat it instead as subdivision curves. And what you can see is it's a bit subtle, but if you look closely, you can see that it just makes everything more round, because it's basically treating it as like a smooth Bezier curve instead of a polygon curve. And so if we look at the end result, it makes everything a bit more round and interesting. And as we increase this fuse value, it makes everything a bit more webby and interesting looking. And of course, like, this now comes with its own problems, right? Like it looks more organic, but also this clear pattern of each of these like holes is very, it's very easy to see. So what you would need to do next is you would need to find a way to break up that pattern, and that's what it's all about, right? When we do procedural things, it's about creating patterns and then breaking up the patterns. So What you could do is you could drive the fuse, for instance. It has a radius attribute, and what we could do is we could, using a noise as a mask, we could, for instance, drive that to be a radius attribute, so that not everything connects in the same way, but that, you know, some of the points connect, some don't. We could add, we could displace the curves also on top of that. There's a lot of things you can do, but I just wanted to show you how with just like 2 nodes, how we have a completely different look. Again, like, right, if I disable this, 2 completely different designs. And yeah, and basically now you have your little flash tool. Thank you for listening to this, and feel free to connect with me and reach out. See ya.